that you want. All right. I'll do. Okay, who has done homework E? Who has done homework D? Okay. Let me pick Adam. What did you find the alphabet?
Well, actually, I just realized I didn't like split a couple numbers that we should see, so I got to redo it.
Okay.
Yeah, I got to
We're not great with it. We got the same. But
All right, great. What did you get for the alphabet?
0.0296 minus 0.0228 s over.
No, the transfer function.
Yeah. It's really ugly.
Okay, okay. 0.0029s?
No.
2964.
296. 29 is fine.
Yeah.
Minus 0.022 s
Okay.
over s plus 0.5. And then s plus 0.406 plus 0.808018. I messed that up. Plus 0.018.
And I'm writing products of terms?
No, this is the next. Just
Just
plus
plus.
0.018.
That?
Yeah. E to the minus s.
E to the minus.
S.
Okay.
Took me forever to do this.
Huh?
Took me forever to do this.
Yeah.
it. 3 hours to get it wrong.
Well, I'll proceed assuming this is right.
Did anybody else get this?
Yeah.
You got it? Okay.
Mine's not factored out, but
Yeah. Everything. That's
All right. So I will do.
Yeah.
Okay. So poles and zeros. I have zeros. I have 1 at. Make this equal 0, so 0.029 over 0.022, right? So that's about 1.3.
3.
1.3, okay. Poles, I need to complete the quadratic and solve the quadratic equation. Did anybody calculate what the poles are?
Negative 0.453 plus or minus.
Negative 0.543.
No, 453.
453.
No.
No.
Okay, like 4, 5, 3.
There you go. 0.126
I.
Yeah.
All right, good.
That's wrong. But
Okay.
We told them it was wrong. That's wrong.
no, the 5 needs to go away. 126 Yeah.
All right. Okay, so you get this by completing the quadratic, you use the quadratic formula to solve it, okay? And yes, if you don't have your quadratic formula, it's also a good idea in all control exams to have the quadratic formula in your cheat sheet. I'm not going to write on the board.
Can we use Wolfram?
No, because you're not going to have computer. You're going to have computer on part of the exam, and then you will not have computer.
Oh, okay.
All right. So let's do the rest of the homework on this. Okay, find the poles and zeros. So Rian did it for us. Okay, forget the poles and zeros. Draw a qualitative picture of the response to a unit step increase in F. Okay, so I have a unit step increase in F. So that means that F increases by 1, okay?
That increases. Where'd you get that? F increases by 1.
Statement?
Continue.
We put point increase by 0.1. You did one.
And read it again. Get the unit step increase in F. Okay? So let's say, since I didn't give any specific time, let's make it simple, and let's say T naught equals 0 equals time of unit increase. So that's what F is doing. It goes from 0, so it increases by 1. Okay? With me? Which means that U prime goes from 0 to 1. And let's say that is time 0. Okay? There's no reason to take T naught anything different than 0 here. Take it 0. All right. So, let's follow the 7 steps. Okay, step 1. Stability. Do we have stability? Both poles, it's a complex conjugate pair, have negative real part, right? Yes.
Is that, so first picture to the left, is that Y?
It's not.
No, U prime
So both of them.
is U. This is U.
Oh.
Sorry. U increases by 1. I haven't, and this supposed to be. U increases from the beginning value by 1. So U increases from U naught to U naught plus 1. That's what it means. Unit step increase, we increase the input from U naught to U naught plus 1. Stability. Both poles have negative real parts. New steady state. For Y prime. Okay? And you found the nominal steady state, so you can calculate. So let's first do Y prime, and then we're going to do the actual. What's the measurement we have? What are we measuring? They give you what are we measuring? Okay, we are measuring the temperature with this Y sensor. Okay, so Y. Okay. And you guys found Y naught earlier in the book. So new steady state, Y prime will go from 0, put some distance here, to what value? To G, appropriate G, which is GF. So it will go to GF of 0 times the change in F, which is 1. So what is GF of 0? Put S equals 0. And you get 0.29 over 0.2, roughly 0.22. Right? So that's 0.29, 0.29. At 0, this is 0. 0.5. And then 0.406 plus 0.018 e to the 0 times 1. That's Y prime infinity. Y prime infinity is going to be the transfer function times the input deviation of infinity. Clear, everyone? Rick, okay? Robert? Hunter? Andrea, question? Are we okay with this? The new steady state for the deviation is the transfer function at s equals 0. So plug s equals 0 everywhere you have s, times the change in the input, in this case f is the input I'm interested, right? Which is 1 since it was a unit step change. And someone with a calculator, please calculate this number, but it's roughly 0.1.
131.
0.131. That much? Yeah, okay. Okay. 0.131. Okay. Yeah, that looks good. Yeah. So it's plus 0.131. Okay? All right. So, what is y going to do? Y is y naught plus y prime. So y prime starts at 0 and ends at 0.131. The actual y is that plus the nominal steady state. What did you calculate y naught when you were calculating nominal steady
He
state?
gave it to us. It's
Oh.
24.24.
24.24. So the y is going to start at 24.24 and will end up 0.131 higher. So it will end up at 24.37. So that's the result of the new steady state. Right? We find that y prime, which starts at 0, ended at 0.131. So the actual y, the actual central output, starts at 24.2, will end up 0.13 higher, or 0.14 higher. What's the deal? 0.14, sorry. Okay, 0.13. Sorry. Yeah, 0.13. So far, so good? Okay, let me roll this up. Some board. So let's do it here, clear so that we can all see it. So what y will do is simply you add the nominal value of y, the 24.2, to the y prime. So y prime starts at 0, let's say it gets a times 0, and will end up at plus 0.13. Y will start at 24.2 and will end up at 24.37. Clear, everyone? Any questions about the first two steps? Okay, first step, yes, we're reaching a steady state. Second step, our steady state is going to be, yes, ma'am?
So did you test the rule of y and y prime separately?
Well,
That part.
I'm asking for the y, but to understand the y, I'm doing first the y prime.
Oh.
Because remember, the immediate what we get from transfer function is y prime. And then to get y, we simply add y naught whatever you got from y prime.
Then why say 37 instead of 33?
Because I made a mistake in algebra.
Or 35 I meant.
That's why.
It's 3/7.
I'm adding 0.13, right?
Yeah, you're right.
So it should be 0.33. No, it's 0.37. No, that's right. There's 24. 24.24. That's right. That's right. I forgot to put the 4.
Okay.
Yeah, okay. Good point.
Um,
I forgot to put the 4, that's why it was 0.37. If I didn't have the 4, it would have been 3.
I think that this is messed up. Because you're doing GFS right now, And that's a disturbance, that's not the manipulated. So that started at, F naught is 10, not 0. So right now you're doing GFC.
I'm missing.
No, I think he's right. No, he's right. He's just doing, he can't use U, he's gotta use D1.
We're doing D1, right? Okay, let's see what we have here. So,
Everything is fine. No, he can't start at 0.
I'm doing GF, not GFC, right?
Right,
Which is a disturbance.
right,
Okay, so it should be D1. Did I say U somewhere?
yes.
So it should have been D1.
And the nominal value
So it
for,
should have been D1, not D1, not. I changed it by 1, right?
yeah. But it started out as 10. F naught is 10.
Ah, F naught is 10. No, well, it doesn't matter what F naught is. This is Y. Y now.
Okay,
So it's correct.
okay.
But it should have been a disturbance. That's a disturbance we're doing. So it's D1 prime. Okay, GF is disturbance, not the manipulated input. That's the correction. Okay? FC is the manipulated. I asked for the disturbance because that was the interesting one. Okay? Remember we talked about exothermic reactor inverse response. What did we find? Of course, there's 0. So obviously I gave you something interesting, something that has the inverse response. All right. So, clear everyone? Everything is correct. Step 3, oscillations. What can I write? All right, here. Step 3, oscillations. Do we have oscillations?
Yeah.
Do we have mathematical oscillations? Yes. I have a complex conjugate. Is it dominant?
Mm-hmm.
Yes. So it satisfies the first condition. How about the second condition, though? Oscillations. So we have a complex conjugate pair is the only oscillation, is dominant. My complex conjugate pair of the roots was minus 0.53 plus or minus 0.126. But B, imaginary part is 0.126. Magnitude of real part .453. Greater than 0.126. They would not be observable. That's exactly the point, that in the plot, you have to do the plot for your homework, don't you?
What?
You have to do the plot.
Yeah, I did it already.
So not observable. A particular thing you can say is that what is the half period? The half period pi over 0.126, which is 3.1 over 0.1, about 28, 27, was 3.14 over 0.126.
27.
27?
Oh, 29.
25?